Welcome friends and welcome again back to Numerical Studio, and today we've again brought a very beautiful example from the world of physics. Half of the problem I have taken from the book Erudov and another half I have created as a challenge for you. But friends, this time I am very much sure that you will not be required any solution for this challenge problem, because if you go through this main problem from the Erudov, you will be in a position to solve that problem easily. So let us go through the problem first. The problem states two particles 1 and 2 moves with a constant velocity v1 and v2 vectors. See, the notation of velocities are marked as bold, so we must take as vector. At the initial moments, their radius vectors are equal to r1 and r2. You can see from here it's r1 and another is r2. Okay, and these are the two velocity vectors which I have marked as v1 and v2 here. Okay. So we need to find out what should be the relation between these four vectors so that particle can collide. Friends, I have touched two main videos in past where I have explained the concept of collision or catching up. If you have not watched those videos, I'll recommend pause this video right now and go and watch those videos. Your concept will be very much clear. Once again, I'm just telling you the brief that at the point of collision, all the particles should be reaching at same moment of time. Okay, so if C is the point of collision, I will expect the particle A and particle B should reach there at same time. Okay. Second, you can see since there is an involvement of vector, so and you can see there is a triangle formation, so obviously there will be uses of vector law of additions. So if suppose that this is a vector A, okay, and this is a vector V, if this is the vector's tail and this is the head, and again this is the tail of vector B and this is the head of vector V, then this vector is nothing but head to tail. Okay, now head to tail method, that is a vector law of triangle additions, so we can write OB is the resultant. So OB can be written as OA plus AB. This we have understood from the vector law of triangle. There are two laws of vector additions. First is triangle and another is parallelogram law of additions. Friends, I have made an exclusive video to explain the law of additions. Please go through that. You can find in the playlist. So using these things, I can easily write that from, if I just consider as O and this is A and this as C, then I can write OA plus AC is nothing but OC. I think everybody will agree with this. The second one, if I just consider this is OB, then OB, this one plus BC can be written as OC. Okay. Now just substituting with the value, OA is nothing but the R1 vector, AC is nothing but the V1 vector. Now you can understand that I'm adding to these two things, right? R1 and V1. Can we add? Anybody? Just think for a moment. Can you add this? Am I doing right? If some of you are telling it is wrong, I'm absolutely telling that they have understood the concept. Why? Because R1 is a position vector. The magnitude of R1 will give us the displacement or distance. Okay. So V1 is just a velocity vector. So you have to convert this velocity into distance or position vectors. So suppose this particle is reaching to point C at time t, then we must write AC as V1t. Similarly, for velocity vector V2, we have to write this as V2t. Okay. Now we should write R1 plus V1t equal to OC, that is we may write at R. Let R be the position vector of point C. Okay. Now for the second equation, we can write similarly. R2 can be written as V2t, vector notation R. Since this R is equal, we may equate R1 vector plus V1t can be written as R2 vector plus V2t. Now just R1 minus R2 is equal to V2 minus V1. Now friends, you see this is the difference of two vectors, right? So it will be ultimately a vector. Again, this is a difference of two vectors. Again, this is called vectors. The resultant will be vector. But this time is the scalar. So what you are getting here? We are getting here vector A, some vector A multiplied by some scalar m, suppose m is the scalar, to vector B. What does it mean? This means vector A must be parallel to vector B. If you have not understood, let me make you understand in some different method. Suppose this is a vector of 1 unit, of length of 1 unit. Okay, this is a vector AB. I'm just consider the length of this vector is 1 unit. That magnitude of vector B, AB is 1. Now, if I just pull this vector to C, up to point C, then 1 unit extra, then this will be entirely 2 units, right? So AC can be written as twice of AB, right? But AC and AB are in same direction. Magnitude wise, AC is twice of AB, but direction wise, AC and AB is equal. So this is the third major concept that is involved in this particular problem. That whenever you are multiplying a vector with a scalar, you will be getting a vector having the same direction, okay, to the original vector. So what we are getting over here? We are getting the difference of the R1 and R2 is parallel to the difference of velocity vectors. Okay, so difference of position must be parallel to difference of velocities. This is the condition of collision. Okay, you just mark it bold so that in objective examination, you no need to do all this calculation. If I just put the magnitude of C, if I just see T is the scalar, so you have to write T in this form. We have to take only the magnitude. So we may write R1 minus R2 magnitude by velocity 2 minus velocity 1. Why I am taking as a magnitude? I have understood. You must have understood that time is nothing but a scalar quantity. So time is scalar, so you are just concerned about its magnitude. And what is the condition of collision? The condition of collision that the difference of initial position vector must be equal to the difference of initial velocity. They must be parallel. Okay. So friends, with this particular problem from the book Erodov, let us try to extend this problem a little bit. Now there are two particles, starts from position vectors R1 and R2, and I have mentioned this, and the velocities are V1 and V2. Find the relationship between A and B such that particle collides. So what I have made you understood that if R1 minus R2 is parallel to V2 minus V1, okay, the particle will collide. Using these two, please find out the relationship between A and B and send your solution in the comment box. Friends, I hope that you are finding the problems from the numerical studios interesting, enriching in knowledge, and you are getting your desired ambition to get the higher marks or scoring the higher marks in the physics. Okay, friends, this is the motto of our channel, to make physics so easy that it is no longer nightmare for anyone. Okay, whether you want it or not, but I'll just try to make it so simple for you that it will be a very easy subject for you. So thank you for your time once again, and please share this channel as much as to your friends so that we can also get a motivation. When our channel grows, it definitely brings a motivation to the creator also. So help us and have a great day. Thank you.